Welcome to this class. We are going to look at something quickly, and it's linear and non-linear differential equation. Now, for a differential equation to be called linear, there are certain things it have to fit into. The first thing we said is the dependent variable and all its derivative must occur only to the first power. The dependent variable, that is the y guy, the one that depends on x, it must be equal to the first power. Okay, and there should not be any term involving the product of the dependent variable and its derivative, like x, y. So it must not be times in themselves involving the product of the dependent variable and its derivative. That means you have something like y, dy, dx, something like that. So it should not be seen, and also there should not be any transcendental function. Transcendental function basically are trig functions, right, of the dependent variable or any of its derivatives. So maybe we talk about something like cos x, cos y, or tan y, all those stuffs. So we have this form dy dx plus p of x y equal to q of x. So that's basically the form. Okay, let's consider this example of differential equations. We have dy dx plus y equal to x squared. So that's an example of a differential equation. We also have the squared y dx squared minus 3 dy dx plus 2y equal to 0. So this actually supports what we said. We said that the first guy must not have the derivative, right, must be to the first power. So basically we have dy dx, and dy dx is to the first power, and then y as well is to the first power. So we have this as well. We have the squared y dx squared. So you must remember that we say there's difference between order and degree or power. Order is basically what we see in the derivative, that the second differential. So but the degree is still 1, right? The power is 1. So minus 3 dy dx, the power is still 1, plus 2y equal to 0. So they must be to the power of 1. So 2y, y is the power of 1 as well as d squared y dx squared. So we also have examples of non-differential equations. We have dy dx plus y squared equal to 0. So for that one, you see that the y guy is squared, so raised to power 2. So basically it do not satisfy the first thing. And then we also have 2 dy dx plus y equal to e raised to power 0. E is basically a transcendental function or a trig function. A transcendental function. So basically that's basically it. And then we have the third one, and we are having dy dx raised to power 2. So it's actually did not satisfy one of the rules. So any of the rules it doesn't satisfy, it annuls everything altogether. All right, let's look at to solve a linear first order differential equation. There are steps we need to take. First one is we express in form dy dx plus p of x y equal to q of x. Then we determine each member in the form in 1. So we'll find out what p of x is, we'll find out what y is equal to, then we'll find out what q of x is as well. So we determine each member in the form in y in 1, and then we also find the integrating factor. So the integrating factor is basically gotten as nu of x, right, equal to e integral of the p of x dx. That's basically how you get the integrating factor. So after that, finding the integrating factor, the next thing is your y will now be equal to 1 all over integrating factor, which is nu of x, all in brackets. You now put your integrating factor times q of x dx plus what c. That's basically how it's going to look like after you are done. All right, let's solve this problem. We have dy dx plus 3y all over x equal to x squared. Then we have to find it when y of 1 equal to 1 over 6. So to solve this problem, the first thing is you remember you write it in the form of dy dx plus p of x y equal to q of x. So you have it as dy dx plus 3 over x y right? We remove the 3 over x one side and then put the y at the other ending. So we have 3 over x, then y equal to x squared. This is because the y is multiplying the 3 over x. So we have dy, we have from this summation, the p of x is equal to 3 over x, and p of x is equal to x squared, right? So integrating factor will now be e ln integral of p of x dx. P of x is 3 over x dx. So we have ln, you take the 3 outside, and then we'll have 1 over x dx. Okay, so we have equal to ln 3 raised to power in x. Remember, 1 over x, integral of 1 over x is in x. So integral of, then you have ln 3 in x will be 3 e in x is equal to x, right? Basically, so we have e in x raised to power 3 will be x raised to power 3. Remember, your y equal to 1 over integrating factor times integrating factor q of x dx plus c. So we have 1 over, your integrating factor is x raised to power 3. Then we have integral of x raised to power 3 dot x squared dx plus c. So we have it as x raised to power 5 dx. So if I integrate x raised to power 5, I'm going to get x raised to power 6 over 6 plus c. So I'm going to have x raised to power 6 divided by 6x raised to power 3. When I put the 1 over x raised to power 3 into that bracket, so that's what I'm going to have. So I'm going to have as well x raised to power 3 over 6, because x raised to power 3 cancels x raised to power 6. So you have it the x raised to power 3, x raised to power 6 minus 3 will give us x raised to power 3 all over 6 will remain, plus c all over x raised to power 3. So y will now be equal to x raised to power 3 over 6 plus c over x raised to power 3. Then when I put 1 in there, y of 1 equal to 1 over 6. So x is equal to 1, and then y is equal to 1 over 6. So 1 over 6 is going to be equal to 1 raised to power 3 all over 6 plus c all over 1 raised to power 3. So 1 over 6 plus c. So we have c is equal to 0. So I'm going to have y equal to x raised to power 3 over 6 plus 0 over x raised to power 3. So y will now be equal to x raised to power 3 all over 6. Let's look at the second question. The second question says something very important for us. Solve x dy dx minus y equal to x squared cos x. So where y pi over 2 is equal to pi. So we have to express in our normal form dy dx plus px of y q of x. So we divide through by x. I'm going to have x dy dx minus 1 over x y equal to x cos x, because actually if I divide x squared, we divide x and we don't have x will be left. So we have p of x equal to minus 1 over x, right? And then q of x is equal to x cos x. So I'll find my integrating factor. My integrating factor will be ln of p of x dx. So which is ln of minus 1 of x minus 1x dx. Okay, so ln, I'll take the minus 1 outside, and then I have 1 integral of 1 all over x dx. So remember, if I integrate 1 over x, I'm going to get in x. So we have minus 1 in x, so which is equal to e in x raised to power minus 1. So we have nu of x will be x raised to power minus 1, which is equal to 1 over x. Y will now be equal to 1 all over 1 over x, and then we have integral of 1 over x, x cos x dx plus c equal to x. Then we have integral of cos x dx plus c. So if I integrate cos x, I'm going to have sine x. So I'm going to have x sine x plus c. So y will be equal to x bracket sine x plus c. So when y, you have pi over 2 equal to pi, that means x is equal to pi over 2, and then y is equal to pi. So pi bracket pi over 2 sine pi over 2 plus c. Then if I multiply by 2, then I have 2 pi equal to pi sine pi over 2 plus c I'll divide it by pi, then I'm going to have 2 equal to 1 plus c, then c will be equal to 2 minus 1, which is 1. So my y now will be equal to x sine x plus c, all right, as the general solution, and then the particular solution will be x sine x plus 1. Thanks for watching. Like, share, and subscribe to this channel. Thank you very much. You have a blessed day.